Hello, everyone, and welcome back. Day two of TestMu conference is underway, and we are glad to have you here. I'm 𝐍𝐞𝐞𝐥𝐦𝐚, Brand Marketing Manager at TestMu AI, and I'll be hosting this session. The Trust Problem, Designing Quality Frameworks for AI-Generated Code. AI-generated code compiles, passes reviews, and ships fast. But speed isn't trust. In a bank, in healthcare, in any regulated environment, the model suggested it is not an audit trial. Today, we'll get into what trust actually requires, the governance frameworks that make it defensible, and real lessons from regulated industries. And we have exactly the right person for it. Neelmani Verma is industry principal at Infosys and heads the consulting group within Infosys Quality Engineering. With 22 years of experience, she is currently building governance and control frameworks for AI-driven systems in regulated environments like banking. A bit of housekeeping before we begin. This webinar is being recorded, so in case you need to drop off midway, drop your questions in the Q&A box as you go. Share your takeaways on LinkedIn and X with hashtag TestMuConference. There are prizes worth up to $15,000 on the line. Neelmani, a very warm welcome to TestMu Conference. The stage is yours.
Thank you so much, Nikhil. Thank you so much. Hi, everyone. I'm also looking forward to this opportunity to connect with all of you. So with this, let me get started. Let me share my screen. I suppose my screen is visible. I'm facing a low bandwidth.
It's visible, yeah.
Yeah, I turned off my camera. I just realized it's a weak signal. Okay, yeah. So good evening, everyone. I want to start with a confession. So everything I'm about to show you, I have built within AI coding agent. And about a third of it was wrong on the first pass. Not obviously wrong, but confidently wrong. So it did compile, it passed its own test, but it was still wrong. And that's the talk for today. So not that AI writes bad code. However, it often, rather it writes better than what a tired engineer would write, like, 6 p.m. or this time on a Friday, on a Thursday. However, the talk is that we've always decided what to trust, and this doesn't work anymore. So there is a paradigm shift to see that quality engineering has to build a new way of deciding. And I have spent the better half of last 2 decades doing exactly that kind of rebuild for banks, insurers who cannot afford to get this wrong. So this is my real, based out of my real client conversations I've been having, especially for the last 1 year. So let's look at this scenario. I'll use my pointer here. So what you see here, here's a function an agent wrote, right? 4 lines, it looks fine. Variable names are sensible. It returns a number. And every test written alongside it passes. Take a second to read it. So the business rule was that the loyalty rate applies to the pre-tax subtotal, right? And never to shipping or tax. But however, the function, what actually does is that applies the rate to the order total, and whatever happens to be sitting in the order total is directly returned. So 3 weeks later, if someone adds a shipping fee to the order object, the discount silently starts applying to the shipping too. And if a junior engineer had written this manually, like a couple of years back, we would have caught it in review. There would have been a comment, a guess, or maybe a to-do list to track it. However, the AI generated code, we would not have caught it in review. And, this is exactly where we'll miss the intel. And it reads exactly as confident as the correct version would have. So that's the difference in the paradigm at this time. So looking on, what exactly is the building base of this quiet assumption. So for most of my career, quality engineering has run on an assumption that we never have to say out loud that the person writing the code understands what it is supposed to do. So the assumption is that the entire foundation of code written once and reviewed once, test passed once, signed off at merge, and trusted forever. This is why a green the single green check mark in our test management tools. That's why that has been enough evidence for 20 years. However, this is where we have built exact 5-step chain into the governance frameworks for more than one regulated client, and which says that the model, it's not a bad model, but it's a model built for a world where human always sits behind the keyboard. So that's why the understanding the intent, even when they got it wrong, is important, right? So the AI generated code doesn't violate the mechanics of that chain. It violates the assumption underneath it. And that's a harder thing to notice because the chain still looks like it's working, right? So what is breaking at this time? So let's look at the AI generated code. What breaks this assumption in 3 ways, right? So the 3 things change. The first one is fluent, but not understanding. So I happened to once review an agent generated reconciliation script for a banking customer that got every arithmetic operation right and used the wrong currency conversion rule. It passed every unit test because the test checked arithmetic, not the rule. And that's the pattern. It passes every check that was a proxy for understanding without actually understanding, right? And there is a shift in the way AI writes. There is no fixed author anymore. In a traditional vendor code review, we would know that there's a judgment you're trusting. The judgment is roughly stable from 1 week to the next. There is, however, with an agent, the underlying model gets updated, sometimes without anyone on your team being told who's actually writing that test, which LLM gets shifted, right? And the assumptions it makes about the edge cases shift with it. So what I tell customers now is that this is closer to a staffing change than a code change. So how in a traditional times we wouldn't miss re-onboarding a new vendor engineer just because they're using the same laptop as the last one. But in this case, even if a model changes, we are not mandating another relearning process for the newer model. That's the difference. Third thing is that trust decays after the merge. So this one QE team already knows that there is a half-baked flaky test, environment drift has happened, a test that has passed reliably for months. It starts to fail now because the CI environment quietly changed underneath. And the AI generated code has the same problem, just it becomes wider. And a dependency, schema change, or shift in real traffic can actually change the behavior without telling anyone that there is a change in the function, right? So what do we do? So where do we look for a framework that already assumes you cannot trust something just because it followed the rules and had access the last time? So not from testing, but from security perspective, right? So 15 years ago, we would have thought that network security ran on the perimeter trust. Once you are inside the corporate network, you are assumed safe, right? Zero Trust threw that out and replaced it with that one sentence: never trust, always verify. Now, this is true for almost every mature framework that I have helped bring into a client, which is to import a discipline that's already solved an adjacent problem rather than inventing one from scratch. So zero trust is already solved, but how do you keep verifying something whose trustworthiness keep changing? So that's the exact point that we have to handle today. So these are the 5 pillars that we'll cover. So I'll go through each one of these, the 1, 2, 3, 4, 5, and we'll watch how. And I also have a live demo following up, which will make it more explicit to understand. So you don't need to really memorize the names, but by the end of next 5 slides that I'll cover to describe each of these, you will find them quite obvious and you will understand them better. So going to the first one, the verify explicitly. So this replaces that. It compiles, it links, it passes the test generated, alongside it. But there's an old idea in test design, which is called the Oracle problem. Do you know what it is? It is said that the correct answer even is, independent of the thing that you're checking. So the code-generated test isn't an Oracle. It's a mirror. So it asks the code, what do you do? And writes that down as an expected answer. So it will pass forever no matter how wrong the code is, because it was never checking against the business rule in the first place. So the fix is not more test, but it is independence from this rationale. So what we do is we push every client that we work on this, write the assertion from the specification. And before you look at what the agent produced, The same way you would write acceptance criteria before a human developer starts a ticket. So if only your test oracle was generated by the same model in the same breath as the code, you'll not have a second opinion, but another echo, right? Coming to the second pillar, that's about the least privilege blast radius. So this replaces giving every AI authored change the same freedom, regardless of what it touches. So risk-based testing already taught QE this lesson for human written code. A change to a marketing banner, a change to an interest rate calculation, that is never going to get the same test depth, no matter how the ticket was labeled. Extend the same risk lens to an AI authored change, which allowed it in the first place. And this is the conversation I've been having with our, mostly banking customers, where a sandbox utility script and a change which is touching the regulated customer data should not carry the same default permissions just because the same agent wrote both. The permissions need to vary from case to case, right? So the scoping blast radius by risk tier, not by how confident the output looks. It is a consulting decision as much as an engineering one. And usually the QE partner in the room who has to make the case for where the line sits, because engineering teams will draw a loosely drawn, boundary of their own, right? So now assuming drift, that's the third pillar. So this replaces a one-time sign-off as a permanent, meaning it doesn't stay forever. There has to be a regular check. What this means, anyone who's chased a flaky test knows this feeling. A suite that was green for months starts failing. And now it turns out that the environment has moved, but the code has not moved. AI-generated code has the same vulnerability, which is much harder to see because the drift cannot be a dependency version, a schema field, or a shift in the data distribution the function now runs against, right? So this is exactly the conversation that I talk to customers for the agentic QE assurance side of my own work recently, mapping traditional SLA patterns into something that keeps changing underneath the SLA. So our old habit was to get a sign off as permanent until someone files a bug. This has to be changed into trust has an expiry date and it expires on a schedule. It has on a drift signal and not like a credential. It is not indefinitely, but rather a certificate bolted to a wall, right? Moving on to the fourth pillar, which is a micro segmented view. So this replaces the identical review depth for every change everywhere. Every QE practice eventually learns that uniform review is a tax on your best reviewer's time. So exploratory testing, where the charters exist precisely because you can't give every corner of a large system the same depth a human would do and ship anything. So the senior engineer's judgment is something which is more rare, and that is what is needed, and we need to spend more time on it where the blast radius is the largest, where there is a more potential for a failure, right? And this is where there is highest leverage things is where consulting can help have a senior reviewer, which is getting an automated gate which gets both in a resourcing model, not just a QA policy, right? Moving on, the last pillar. So this replaces continuous attestation, which replaces a static test report, which is signed once, but rather a continuous process of attestation. And this is primarily more important for the regulatory industries, where we know that the instinct from the audit trails and traceability matrices, a document that says tested once on this date is worth far less to an auditor than a living record. So more of observability into what was checked once and then a rule is set. However, this is a governance layer that we need to include. It's an evidence ledger, not a certificate. And we need to keep a record of which agent version generated the change, which rule it was verified against, when was a re-attestation done. And that's where, why do we trust this 6 months later? We have a traceability back to it. And instead of shrugging and pointing it to a merge date, which happened much earlier. So let me stop talking about the drift in a more abstract and a theoretical way. Rather, let me apply this to a demonstration, and let's look at it. So let's move to the demo with this. I'll move to the full screen of this demo. So what you see here on my screen, this is just to give you a context, the day 0. So this is the same loyalty discount function from the opening story, the first slide that I showed you. So by this time, what has happened is that it went through the process I've just described. Look at the left panel here. So the assertion isn't checking the code's own logic back at itself. It is written straight from a policy document, and the discount is applied to the pre-tax subtotal and excludes the shipping and tax, and that's it. So that assertion would exist even if the code underneath were completely different. On the right, this is a trust score. So this is a 96, what you see here. This is logged, attested. So this is precisely the evidence record which you want to see if I was auditing this change for a banking client, which agent generated it, which version of the policy it was checked against, who reviewed it, right? So this is the verification log that we maintain here. And critically, when it is due to be looked at again, right? So now let's look at, there is the process goes on, and let me take you to another, couple of days down the line. Let's look at the day 12 in the day 45 cycle. So the day 12, this is the kind of change that would never show up in a pull request for the function itself, because this is not a routine auto merge dependency. Every QE team has lived the story with a flaky test that broke for no visible reason, but it turns out that something 2 layers below the code where you are looking, it has moved. And you see the score here that this has dropped now, right? So this is the first real hit. We have not touched the code, but we see that the drift has been detected by the system. Let's move on. Let's come to the day 28. And this is where a new field enters the order object upstream. So because original assertion was written against order total, now there is a explicit list of what belongs, to that number. A new field has silently creeped in, and the assertion didn't get weaker, but the world underneath it got wider, and now the same formula works incorrectly, right? That's where the defect, the drift detection is showing up on the right panel. Now, moving on to the day 45. Now, what has happened? There is a new, there's a production code, a production data dump which has happened to the test. And now the real production traffic is exercising all edge cases, boundary conditions, and the original test data, which was never earlier applied. Now look at the badge. So verified has become drifting, right? What you see here, it is clearly drifting, and it has gone below the threshold, and the score has crossed the line where this organization policy says re-attestation is mandatory. It is not optional. So this is a guardrail we have introduced at this point. Let's look at the gate response, how this is, interacted by the system. So this is what happens, so if you see the gate response, this is the automated gate response. This is what happens automatically the moment the threshold gets crossed. Nobody will notice it otherwise on a dashboard or file a ticket, but the first 3 steps, these are automatically triggered, right? So the function's blast radius auto-restricted itself back to the internal traffic only. Re-verification job has been triggered, right? Using the current state of the world, not the state it was verified against earlier. And here's the part I want to, I want you to remember. So the new score, let me run the re-attestation. So this is the re-attestation score. So now new score is 89. It is, if you recall the very first point we started, the score was 96, right? And that's not deliberate that it has dropped to 89. So this is not a bug in the demo, but the function now carries history to it. That it has, because of the 2 prior drift events, the model keeps that history in the evidence ledger that it gets watched more closely in the next cycle than a function with a clean record would. So trust isn't reset to a full cycle and a clear run, after this part, but it accumulates the memory the same way a credit history would do. And that's a whole loop. So we need to run this again, and it will start from this point onwards and not a 96. So with a record at every step, that's what the loop is. Never trust, but always verify, and actually looks like running in software instead of a slogan on a slide, right? So let's get back, with the takeaway for all of you in the from this. Let me go back to the pack. So what this changes for the QE teams now specifically, now you've looked at the practical demonstration or translation of this to a QE team. So the metrics, the specification coverage, attestation freshness, this is where, we move ahead of the line coverage, pass rate, as these are the specific numbers that leadership looks and tracks, right? And in terms of roles, someone has to own the risk tier assignment, the risk re-attestation trigger, and this is what will be the custom decided for each organization based on their risk appetite. And most organizations I work with have not named that role yet, but assuming this will be usually the first thing that we recommend when I am brought to assess a client's AI QE maturity. Then coming to the tooling, this is this is a drift monitor which we just saw, and an attestation ledger which becomes core to the pipeline as the test runner is today. So none of all of this, is a testing tool purchase. It is all an operating model decision which I'm talking about. So any tool can be brought in here, but just the framework is what I wanted to demonstrate to all of you. And this is exactly the kind of decision wherein external QE, like a consulting perspective, sits at the table, and we've watched dozen organizations make this shift already. And we can tell, that these are the 5 pillars which we just spoke about to prioritize first, and specifically according to your risk profile, right? So now 3 things for you to carry out of this room. Let me just read this out. So syntactic correctness is no longer a proxy for the semantic correctness. The AI generated code needs a distinct QE lens for intent alignment. Very, very important. Next is the traditional coverage metrics. They are no longer enough. Team needs to be more layered and continuously renewed on the verification. Not just a single pass rate or a fail gate would not suffice any longer. And lastly, trust must be engineered and not assumed that it is passing once, it will always pass. And there need to be governance checkpoints and escalation paths in the SDLC, and same scrutiny that you would give to a unfamiliar vendor's code, because there are things changing underneath with respect to the AI models, right? And before we close, just a last thought from my end. Trust is not a gate that you pass once. It's a credential that you keep renewing. And that's the true for the code that our agents write. And it's been true for every quality framework that we've helped our client build, the frameworks that last for longer and built to be re-earned, not signed once and forgotten. And that's it. That's all from my presentation. I would like to take your questions now.
Thank you so much, Neelmani. It was a great, insightful session. We'll just quickly take few questions. I'll just pin on screen. Should AI-generated code face a higher quality bar than human code, or the same one?
They need not necessarily a high quality bar, but I would say there are different metrics and parameters for an AI generated code compared to a human written code. So the metrics differ, and that's where assurance comes into play, the agentic assurance. And certainly it is, what we follow is LLM evaluating LLM. So that's an independent, but not, of course, the same model, but it's an independent assessment that matters more. And in this point.
So we'll take up the next question. It's a little lengthy one. Someone has noted from your session. So yeah, because like you noted, the traditional QE assumes the code author understands human intent when moving away from the old contract. So how often should a framework reevaluate AI-generated code to ensure no silent functional drift has occurred?
I would say there needs to be observability brought in, and it has to be dynamic, and every time. We cannot even wait for a day for the code to be reassessed. It has to be dynamically built in and auto-triggered. So there is no, but of course, I mean, there can be a threshold on, when different SOS signals can be triggered. That's based on the risk appetite of the organization and the systems we are dealing with. However, the checks need to be, I would say they need to be integrated in the system so that there is nobody, actually monitoring, but system alert the respective teams of their own. So there need to be more observability weaved into the system.
Right. We'll take one last question. Do you track which code was AI generated? Does that label even matter downstream?
That's an interesting one. At this time, to be frank, it's a mix, the human written code and the AI generated code. However, we are seeing a tremendous shift in the way the percentage is really dwindling, and we're seeing more and more of AI generated code. So it's not about human generated or AI generated, but the paradigm has changed. So the framework that I spoke about, that is what matters more, and that will work for even a human written code. So there needs to be a different thought process in doing assurance for a system which is written by AI itself, right? That's the thought I would like to put it as. It's not that our perspective needs to change on the who's authored the code, but rather the framework of how we are validating it needs to change.
Very rightful said. Thank you so much, Neelmani, for your time. And thank you everyone for joining. Stay tuned for further sessions.
Thank you.